your friends. Very good evening. I welcome you all to this channel, YouTube channel of course. And today our discussion will be on this one, what last time we had, that is on intake facilities. That is the first step for the public water supply system. So that is why we have taken up this particular topic on intake, these facilities, its planning, its designing, its operation and construction, maintenance, etc., etc. So we went up to this in our last discussion. I have kept this, the diagram still today also, on the board, so that we can refer to the same diagram while discussing further into our on our next sections like intake gate. So we discussed up to intake conduit. So I'm not going to repeat that one. Intake conduit, as you understand that here, I think you have understood this, that when right from the river or the surface water source, so that actually taken to the pumping station or suction well directly from where it may be pumped, or it goes to the pumping station directly, or that the suction well or intake well, and the pumping station is placed at a location, convenient location also, from where the pumping operation could be done. Now to continue this our discussion on this particular topic, so here in fact see that just see this one. Okay, so this will be our this intake gate. Intake gate means this gate. Okay, so that is why I have kept, so that every time, because it is difficult to draw every time the same type of diagram also. So that is why I have kept it, so that I could refer for the next part of the discussion. Intake gate we have written here. So this is intake gate, as I have told earlier also, and I am not repeating this one, that how intake gates are configured or arranged also, on an intake well also. And that suppose this intake here some hole, suppose this is the hole, say intake over this, and from the top actually there is a spindle. So from the top here, this actually is operated, it could be closed or it could be opened, right? So I am just giving an illustrative this one. Suppose this is the hole on the board you may consider the one face of the intake well also. This is suppose one hole, and similar this hole on the same surface also at different levels, different tires on different faces also, on other faces also. And when you want to close this one, there is a sliding gate also, that is the sluice valve also. So suppose this is the gate also. So this actually is connected with the spindle from where it is operated. So it is pushed down, so that to close it, and it is pulled up to open this one. I think you have understood this, so that water could enter through the port or hole on the intake well also. Okay, so that this for intake gate, actually see that I am erasing this one. Some I am to erase because I am to create some space. Okay, so this actually I can erase this part also, because I have already discussed this and it is captured also in our last video, right? So this also we can erase up to this. Now intake gate, regarding intake gate, I am writing here. the lowest part of the intake port or this gate, so that actually to be located above 0.3 to 0.6 meter above the bottom of the channel. That means the lowest is suppose here, right? This is suppose like another say. So at different tires also. So here actually that has to be, you know, with respect to the bottom of the channel. Suppose this is the channel bottom also. Suppose this is the channel bottom. So that below that it is inserted. So from with respect to the channel bottom also, that intake gate should be at least 0.3 to 0.6 meter above the bottom of the channel. So this would be the lowest. I am writing in short because the space is limited. Lowest gate 0.3 to 0.6 meter above bottom of or above channel bottom of or say channel. Okay, just 1 minute and save the time for you. Okay, just 1 minute. Now it is 6:43. So 17, 21. So this is the location, recommended location of the lowest gate. The highest gate also, that highest gate is set, while the highest one, the highest gate, that should be set 2 meters below normal water level. I am just erasing this one. So flow I am showing here. Normal water level, say. Okay. Now the velocity through the gate, based on that, velocity through the gross area of the ports, the total, this one, it should not be exceeding 0.3 meter per second. That is referred by AWWA. I repeat it here, that this actually, you know that AWWA means American Water Works Association, because our this country's the CPHEEO Manual or IS code has not specified. There is no IS code on IS intake this facilities or intake design also, right? If you happen to get, then let me know. Okay, so this actually here we have taken this value from American Water Works Association, and while the CASIM, which is also a very standard internationally reputed book, so he also mentions that, or rather now they, because the multiple authors are there, led by that Sir CASIM also. So that is a very very popular book. Meter per second, that is CASIM. So accordingly you can you can set the velocity also, right? And this actually, see that this is the gross area also, the net area also, that is 0.08 based on that. Qasim's actually has taken this value. I think that this is on net area, but let me check once again. Okay, 0.08. 0.08 means 8 centimeter per second. Okay. Yes, effective area of the gate. This is 0.08. So that is in terms of the opening area or effective area, while this one is the gross area, right? So when you will use this one, right? So suppose the discharge is there, Q design, you are designing based on that Q design value, then this actually is entering through this one with a velocity of 0.3. This is meter cube per second, say. This is meter per second. So this will be giving you the area of the intake, say area of intake in meter square. So total area of that will be in, will be this one. That is the gross area. When you take this one, American AWWA value, gross area, that means the total area, right? The solid part also, and including bar also, that one. But when you use this one, Qasim's this 0.08, that is based on the effective or the net area, which actually is the opening area only. Suppose this is the gate, okay? Now suppose we have used a bar like this one, right? This is the gate. So here actually this bar, if it is there, then in that case actually this will be the solid based on that solid area, total area. Based on this actually this will be the opening area, total opening area also, right? So this actually will be applicable for other intake ports also or gate also. So this is about the area calculation. And intake creep I am not discussing it here. If time permits, I will discuss maybe that one-to-one discussion or personal interaction. If we have got in near future, we will have that in our discussion. Intake creeps, because that is a submerged actually. This is suppose on the bed, the creeps structures are there, and above that the water column is there. So it is actually through the head of the water column over this actually in the river or reservoir also, that actually is raw water is collected. Okay, there also the screen or gates that will be there. And strainer, the bell mouth strainer, this actually there may be different type of this is one type. So that is a bell mouth strainer. If you use the strainer as the bell mouth also, then in that case actually the bell mouth that is, it is something like that. That is, this is bell mouth. So this is the porous, this one, right? So this actually bell mouth strainer is this, while the basket type cylindrical strainer also is there. Cylindrical strainer means this kind of strainer. That means entire this one is strainer, right? So this would be here. So this is cylinder. In the top also, that the strainer may be there, may not be there. Okay. So for bell mouth, this one strainer, and this is the cylindrical, all strainer, both a strainer. So this is the cylindrical, this is the bell mouth. For bell mouth actually, the velocity criterion, that is 0.15 to 0.30 meter per second. While the opening of strainer holes, that actually 6 to 12 millimeter opening, this one, of the strainer holes, the holes which will be there in the strainer. Suppose if I show this way, suppose it is a bell mouth shape, right, and there is a strainer, so the holes are there, perforations. So the dimension of this each hole, so that will be 6 to 12 millimeter diameter, okay, rounded, this shape. Gross area of the strainer 2 times the effective area, that means the area of holes, and the total, when you will calculate the total, this one strainer, this one, right, so that actually will be 2 times the opening, this area also, 2 times the effective area also. So first you will calculate your effective this area, that means based on this velocity. So Q design by this velocity, right, and then you know that you will get that the area, the effective area of opening also. Then you know that based on that, what is that, how many opening perforations are there, and what is the perforation factor also, that means how many holes are there in the gross holes also. So that actually proportion may be taken as 2 also, that means the gross area to be calculated based on this guideline, that is 2 times the net area or effective area or opening area, remember this, okay. And cylindrical strainer, that actually it should be 0.6 to 1 meter below lowest water level also, below lowest water level. Strainer, if it is there, strainer I showed earlier. So recommended range is that 0.6 to 1 meter, 0.6 meter to 1 meter below LWL, that is lowest water level. And the other part, if the holes are there, then there is another recommendation you can get from standard these references which I am mentioning here, right. So this is more or less this one. So just to summarize this one very briefly, that the intake, this ports or the gate design, right. So this gate actually, that how to find out that intake, this gate, the lowest gate also, this kind of this, the bars may be there, right. So in that case actually the velocity should be this, and this is the based on the gross area, this is based on the net or opening area also. Accordingly you can find out that what will be the dimension of gate. And then detailed design, you can get in the other books. I will give the references later, from where you will get that how to calculate this one, right, and how to configure the gates, how to decide about the layout of that, and how to configure the gates in different tires or in different in the same face, in different layers also, that may be there on different faces. So all these configurations you can read, you can get from these other books, like the Qasim's book is the very good book that way. So elaborate details regarding design is there, you can get. Then this is that one. So options are there, either gate, or in such case actually when directly taken, the strainer, that is strainer, bell mouth strainer or cylindrical strainer, put here, right. So that actually taken this one, or what is there actually, either through that gate it could, like that, you can here, if you have gate also it could be like that, or you can say that the inlet is there, suppose here, inlet, so that strainer, the bell mouth strainer may be there here, or cylindrical strainer may be there. So different strainers could be put, so that before it enters into the pumping system also, the suction well also, it is screened out, so that clearer water, relatively clearer water, can be pumped also, because the pumping otherwise will be, choked. The pumping system or the pump operation will be very much affected if the, these, materials, some materials, as I have already mentioned, that is the fish or floating bodies also, if that chokes the pipeline also, then the pumping operation will be affected severely. So that is why this is avoided absolutely. And also you see that the fine screens, this is this screen actually, this is right at the entry level, and after that actually the finer screens are placed here. So I am discussing regarding this fine, or that screen or strainer here after this. So I am erasing this one, right? So first is that at the entry point, it may not be a tower intake. In case of tower intake, the gate may be like that, right? It may be for other types of intakes, it may be strainer type. That means in the inlet line, that is set with the inlet conduit also. Okay. Now when it enters into the suction well also, before pumping also, right? There should be another strainer, that is the coarse strainer also, right? The coarse means the materials which are unwanted, means for pumping also, so that must be eliminated also. Okay, so that is there. Then this is the fourth part, I suppose. Third is the intake gate. Fourth is the screens and strainers or racks. Now bar racks means, suppose this kind of bar you have provided here, this one, right, inclined this one, and here the water is entering into that before the pumping is done downstream of that, right? So there may be bar, the perforated this bar like that. This, if you slant or incline this one, so this would be like that. So bar racks may be like that, and the bar size, that is 12 to 20 millimeters. Opening size of the bars, between the bars rather, that is 25 to 75 millimeter. Now in this connection, let me tell you one thing, because it might not have been clear also, that what is screens, here also screens, there also screen, right? So these screens actually at the, here I repeat this one, at the entry point. This is the bar racks here. This bar racks is that after it is this one here enters into that. Suppose the before pumping actually the water is actually, this is placed like that, right? So this is, if I could show like that. So this is, suppose this is inclined, right? This is inclined like that. So the water is coming through inlet conduit, entering into the intake well also. Then just after that the pumping system that is there. Okay, so that will take the water from here and will pump this way. Okay, I am showing the line sketch and very very much draft kind of sketch. Okay, So this pump will be kept here just downstream of this one. The water enters before, in the intake well itself. So water enters through that one. So coarse materials are out, right? And the sizes and the openings all are discussed here. So then it enters into that, and then the pumping that was there, and the fine screen, which we will discuss little later. So that fine screen, while this is the coarse screen before pumping, the fine screen will be placed after that, just before the pumping, this one. Either this may be like that, right? Or it may be, in a channel or so that is there, so that, you can place the fine screen also just before pumping also. So suppose sometimes the partition wall like that, right? And one alternative opening that is there because of the maintenance. So when the main water is coming on the bay also, it is divided, split into two, this one, but one is closed, say, another is open. So this time another screen is put here before it enters, it goes to the pumping, this one, because the pump will be kept after that, right? So different types of systems may be there, but just before pumping, that is the fine screen. Well before that one is the coarse screen also. So gradually this will be screened also. So opening, and the velocity should not exceed 0.6 meter per second. Okay, based on the net open area. So this is, I am simply writing net. You understand this, net opening area. That means effective area. The screens, this is, while this is the bar racks, and the screens, actually this is another options also in the under this. So screens actually may be basket type screens, means it is a sort of basket, like laundry basket. So there actually the perforations are there, right? Like your tea strainer also, for tea, for screening that, the tea leaves from the tea what you drink. So that kind of basket also, this would be something like that. I can show you here. So this would be the basket type, this one, right? All are perforated here. Maybe top, maybe bottom also, side, all around, right? So this is the basket type also. So that will be that will be placed, as fine screen also, or even coarse screen also, basket type. Another is the pane type. That means this, the window pane like that. So this would be like that, fins type. So there actually the clear opening. That is 10 millimeter. You see that here bar racks opening is this, much bigger, larger than this, and velocity 0.6. It should be less than same. This is actually, should be less than that. This is actually should not be greater than, more or less same, meaning is same. So this is referred by AWWA, American Water Works Association, right? Now Qasim's, according to his book. So this is, I am creating space over here. So Qasim recommends, Qasim books rather, that for bar racks, that is Qasim, that is velocity, based on a net or open area also. Now coming this fine screen. This I have already mentioned, in fact, 0.08 or so, right, earlier. But different type of screens are there, that is why I have repeated here. So this would be, the fine screen, the velocity should not exceed 0.2 meter per second based on the net open area also. That means what you calculate, that actually will be net open area also. That means the effective area or opening area also. Now this actually the velocity here, you see that fine screen, actually it's not necessarily the velocity will be lesser than this one, because here you are taking that velocity is this. That means here the larger or higher velocity you are permitting, but in this case actually the velocity what you are using, right? So that actually 0.15, right, that way it is kept around that 0.15, which is less than 0.2 meter per second or so. That velocity actually, so that the area will be more for fine screen, because the screen area that will be quite fine, so that is why its opening area will be more, right? So and the velocity to be allowed through that will be naturally lesser, because otherwise the screen will be damaged, right? And the unwanted materials may enter into that, because it is placed, as I have told, I repeat it here, that is placed just before the pumping also. So that is why it must be must be properly placed and properly designed, otherwise the entire pumping system, particularly the pump operation, that will be very much affected also, requiring very frequent overhauling or maintenance also. Now so these are the these are the different components, the major components, right, of intake facilities also. Now next comes the suction pipe for low lift pump. Suction pipe, that is this pipe. So pump, as you know that these pumps, actually I'll just little elaborate this one, right? So I can erase now, because it is already captured in the video and possibly you have understood. If you have got any difficulties in understanding repeatedly, I am trying to sort of communicate that it will be discussed in personal interaction for the registered viewers also. Every details we can discuss in more details also. The details could be discussed during that time. Okay. And additionally you have to read also, consult with the references what time to time I am telling during my discussion. So now the suction, I am erasing this also, because I have to create this, but I want to keep that drawing, there, this drawing, so that every time we can refer to this. And this is such a sort of detailed drawing also. It is not possible to draw every time, so that is why I am keeping it. So suction pipe means, suppose this is the when it is placed horizontally, say. So this is this one, and this is the outlet also, delivery pipe. This is the suction pipe, and when it is, say, vertically placed there like that. So here the pumping assembly are placed here in a casing also. So here multiple pumps may be there, and when it is entering into that, through that I give that the suction, this one. So it is entering into the system. So this is the suction, and here the delivery system, that is the same delivery. So we will discuss in subsequent lecture, in our this particular lecture series also, in this that how the conveyance system is designed. So the conveyance system, separately this topic I will discuss later, but here which is needed also right at this moment, just to understand that. So I have here, discussed or have been discussing this. Okay. Now here the velocity in the pipe should be between the suction, this one velocity, right? So this should be 1 to 1.5 meter per second. And it is pumping, so flowing full. So from the velocity you can find out the surface area of the, or cross-sectional area of the suction pipe, also from which pi d square by 4, as I have told in my last video also, you can find out diameter also. And then nearest diameter, available in the market, you have to choose ultimately. Because you cannot choose according to your calculator. Remember this point is very important, that you are, suppose diameter, you have got a very, unusual kind of, unusual in the sense that it is not a very, the diameter, which is suppose 11 centimeter, you can't get 17 centimeter, you can't get, so 10, 15, 20, like that, right? So that actually the nearest higher diameter is normally selected, unless otherwise stated also, and as I have that part I have discussed so earlier. So this is that suction pipe, the velocity. This is the velocity through suction. The difference in height between the lowest water level and the center of the pump shall not be more than this one. That means the difference in height. Remember that. So difference in height, I am writing only this one, height, but you kindly note or listen to my lecture so that you can remember this one. Difference, or you can take note also. Difference in height between lowest water level and the pumping center of the pump, The center means here, suppose this is the center line, and in this case actually this is the center line also. So based on that, actually that would be decided. So shall not be more than 3.7 meter. When the level of the pump, right, is much higher from the lowest water level also, then the suction distance should be less than 4 meter also. Suction distance should be less than 4 meter. Here 3.7, it should not be more than that, but when level of the pump is much higher, then in that case higher than the lowest water level also, then in that case you can take little bit allowance, more allowance you can give, and up to 4 meters. A pump located below lowest water level with a flooded suction valve is preferable whenever justified economically. That means when you are pumping, it is always advised that the pumping assembly also, this is submerged below lowest water level. Okay, below lowest water. That is, it works so that it operates under submerged condition. So that is called the submersible pump also, which acts efficiently, functions efficiently below water also. So there may be two types. Suppose your pump is here, right, and your lowest water level here. So the pump has to lift that one. So that is a suction lift. And when the pump is suppose here and the lowest water level is here, that is under, it is functioning or operating under submerged this one, and that is desirable, because in that case actually priming and all these issues do not come, and pump works efficiently also. That is why economically, if it is permitted, then it is recommended to go for the submerged this pumping also. Now backwashing pipe for cleaning the foot valve and strainer. The foot valve, I have already discussed this one. There is a foot valve, so the non-return valve also. Here there is a non-return valve also. This is something like that. So that when pumping is stopped, so that it cannot, then go down. The water enter is emptied also. This is prevented, right? This is, the water level inside that one, which is already there, right? That is not allowed to go down also, and causing the empty this one here, right? Leading to an empty pumping assembly or pumping this one, right? So that is why this actually is prevented by the provision, keeping a provision, or by providing a non-return valve. Non-return valve means this is something like that, right? So when this is movable, right? In very hand pump also that system works actually. So when water is coming, so this valve is opening because of the water pressure. But when water is not there, this is not operating, then in that case this is actually closed. So that actually, so that it keeps the water column over that, and always pump gates, a sort of, a permanent water column inside there, so that the priming is automatically ensured also. Now backwashing pipe for cleaning the foot valve, because the foot valve also may be, may accumulate this, materials also. So that is why to that backwashing pipe, so that the substances which are not desirable also, that could be, kept out also. So backwashing pipe, the velocity in the backwashing pipe should not be less than 3 meters per second. This is the backwashing of foot valve. Foot valve, the other day I have discussed last time, but this is the how it works I have discussed today. So that is actually, this is like that. So this is the pipe say. So when normal operation, this foot valve will be open and the water will enter into there, right, into this. But when it is not operating, this is not operating means the water is not there in the pipe, then this will be closing this one to prevent the falling down of the water and emptying this one, requiring again the priming operation also. So this actually, the velocity in that pipe actually, backwashing pipe, there is a backwashing pipe side either this way or this way, or second this one, which is otherwise closed when it is not needed. So not needed. So velocity that actually should not be less than 3. It should not be less than 3 meters per second. Treated water shall be used for screening, but otherwise if the water itself, the cleaning water itself is suppose containing the unwanted materials, then in that case actually it will be remaining even after cleaning also. So that is why the treated water, which is free from these substances also, that must be used while cleaning the foot valve through the backwashing pipe. The quantity of backwash water should be 1/3 of the flow in the suction pipe. That means the quantity of the backwash water equal this, 1/3 of the flow in the suction. That means how much water flow has occurred during this suction, right? So total amount, say this is QS suction, this one. So your backwashing QB, say, that will be 1/3 of QS. That is the total amount of this, or you can say that actually V, if we write that V suction, V backwashing, this is the V volume. This is not velocity. Let us take, this is the volume, capital V, volume. So volume of the backwashing this water to be used will be 1/3 of the volume of the total volume of the water which has been pumped through the suction pipe. So today we will end up here, and next time onwards we will focus on the numerical examples which we will solve here in the class, right, this class, and the design class also time to time we will see, right, one design example, but small, because the design class we cannot take here very detailed design, because in undergraduate level it is not required, number one. Number two is that for professionals actually the detailed design will be required, but for examination purpose it is not required, the detailed designing also, and this actually doesn't fall in the scope of the this course. Because that otherwise the time will be one design itself, intake design, if you do that will be 7 days or so, half an hour video, so that time we cannot afford also. So that is why we will discuss it, a simple design problems. So next day we will discuss that, we will do the design examples also here itself, so that you can understand this. Thank you so much for your patient hearing. Okay, good night.